All right, let's do some examples for refraction. Let's remember, first of all, Snell's Law. That's the big equation. N1 sine theta 1 is N2 sine theta 2, where you have light coming in from one medium, hitting the surface of another medium, and you want to know how the light changes direction. So theta 2 might be the angle of refraction, theta 1 is the angle of incidence, and the index of refraction n tells you about the material, how fast light moves in that material. And we had index of refraction for air was 1, water was 1.33, and glass was 1.5. And then we also talked about critical angle and how we could use Snell's law to calculate that special angle for a material when you're going from a more dense medium to a less dense medium that allows the light to just have what's called total internal reflection. So let's do some examples and see what the calculations look like. Let's say we have light incident on glass from air at an angle of 40 degrees. Calculate the angle of refraction. So I'll draw a little picture just so we have in our mind what's going on. Here's the air, here's the glass. Light's coming in, hits the surface. We have the light comes in at 40, and it'll come out into the glass at some new angle called theta r. And I want to know what's this theta r. So we use Snell's law, N1 sine theta 1 is N2 sine theta 2. So we're starting in the air, so N1 is 1. Sine theta 1 is sine of 40 equals, we're now going into glass, so N2 is 1.5 sine theta r, which is what I want. So I have sine theta r is 1 over 1.5 sine 40, which says theta r is the inverse sine of sine 40 over 1.5, which is 25.4 degrees. Now before I box it, I try to see, does it make sense? And the way I ask that is I say, should my angle get smaller or should it get bigger for this case? And remember, the rule says if you go from less dense medium to more dense medium, your angle should get smaller. You're being bent towards the vertical line. And of course, the opposite is true. If I'm going from a more dense medium to a less dense medium, I'm bending away from the vertical line. So it should get bigger. Well, here I'm going from air to glass, so I should get smaller. And I went from 40, I'm now at 25. So yeah, makes sense. I could box it. And that's basic refraction, Snell's law style of question. Now let's do a more complicated one. Let's say this time I have 2 layers. Fancy. So let's say I have air, and then I hit glass, and then from the glass I go into water. And so let's say it looks like this. Here comes the light in the air, hits the surface of the glass. It bends. So it'll come in like this. Then it hits the surface of the water. It'll bend again. So it comes out like that. So what do we have? Let's say the light comes in at 30 degrees. Goes into the glass, let's say at theta 2. Well, notice just by symmetry, if it comes into the glass at theta 2, then it's the same angle when it hits from the glass to the water. That's also theta 2. And now when it tries to go into the water, it's some new angle, theta 3. Okay? So the light hits the glass, goes through the glass, and goes into the water. Just like if you actually had a glass of water sitting on a table, and the light's going into it. From the air to the glass, into the water. And I want to know, find theta 3. What's the angle of the light in the water? How do I solve a problem like this? More complicated, double layer style of problem. Well, hopefully, your intuition tells you, let's just use Snell's Law to do air to glass first and figure out what will be the angle when it gets into the glass. Once I know that, then I'm going to use Snell's Law again a second time, where this time I'm going from glass, I know the angle now, and I'm going into water. So we use Snell's Law twice. Let's try it. N1 sine theta 1 is N2 sine theta 2. Okay. What's the one stuff? Air. So N1 is 1. Sine of 30 is equal to 2 stuff is glass, 1.5 sine theta r. All right, so just skipping a step, it's the same steps. Inverse sine of 1 over 1.5 sine 30. What do we get? Theta r is 19.5 degrees. So I now know what is the angle of refraction in the glass. So now the light in the glass is coming in at 19.5. Fine. That's not my answer, because I don't care about the glass. What I want is the water. So I continue along and I say, okay, now that I know this, let's use, I'm now going from the glass, so N2 sine theta 2, I'm going to go into the water. N3 sine theta 3. All right, so N2, what's the 2 stuff? Glass, 1.5. Sine theta 2, well, I just calculated theta 2. It's 19.5 is equal to, what's 3? 3 is the water, and 3 is 1.33. Sine theta 3, which is what I want to find. So again, theta 3 is inverse sine of 1.5 over 1.33 sine 19.5. All right, so 1.5 over 1.33 inverse sine, I get 22.1 degrees. All right. That's good. This works. I was able to figure out, for a double layer problem, I'm going from air to glass and then continuing into water. How do I do it? I'll just use Snell's Law twice. Use Snell's Law to figure out the intermediate step, which is the middle, the glass. And then once I know it, just use Snell's Law again as if the air doesn't exist and you're just going from glass to water. Now, I'm going to trust that if you sat here and thought about this for long enough, you would discover something that I'm about to give you directly. Because, of course, I don't want to have this video last for hours. There's a faster way to do this. Note what we did. Note we used this equation, and then we used this equation. Think about this. If n1 is equal to this, and that thing is equal to n3 stuff, doesn't this mean the same thing? A equals B, and B equals C. Then shouldn't A equals C? Isn't this a logical truth? If I take this thing and I call it A, and I say A is equal to this thing, which I call B, if A equals B, and this stuff says that B is equal to C, then can't I just do A equals C directly? And the answer is yes, you can. So what I could have done, since I don't give a crap about the glass, I'm not asked at all about finding theta 2, all I really had to do was say n1 sine theta 1 is n3 sine theta 3. So 1 sine of 30 is 1.33 sine of theta 3. Theta 3 is inverse sine of 1 over 1.33 sine 30, which if you get your calculator you find is of course 22.1. Isn't that nice? So now you know. You had to see it for yourself. You had to go through the steps of doing Snell's Law twice before you know that you could use this shortcut. You had to prove it to yourself. And here we've proven it. We did it the long way, got an answer. We did it the shortcut way, and it turns out the answers are the same, which they should be, of course. Now, the only time I would suggest you not use this shortcut is if in the question I asked to find theta 2 as well. Well, obviously, if you have to find theta 2 and theta 3, then you got to do both. But if all you care about is the end, if all you want is the final angle at the very end of the day, then no matter how many layers are in this problem, you could start at the beginning and then finish at the end. So if this were 10 layers, then I would just say n1 sine theta 1 is n10 sine theta 10, and skip everything in between. Now, I say this knowing that technically speaking, you shouldn't do this because it's possible for you to set up a problem where in the middle you get a critical angle problem, where the light cannot pass through a layer. And then, of course, everything falls apart. But I will attempt, when I make my exam questions, if I give you one with multiple layers, I won't have that trick. You can assume the light will pass through. And that means, if all I care about is the final angle of refraction, then don't worry about having to do the middle steps. If you forget, or you don't know if you can do it, then just do all the steps. That's fine. You still get the same answer. But I'm just letting you know there is a shortcut, and a shortcut is valid. It works. All right, let's look at a critical angle now. Here's a question. Calculate the critical angle for glass. Or sometimes I'll say define the critical angle for glass, whatever. I want to know what's the critical angle for glass. That means I've got light, incident. It skims the surface. The angle of incidence is the critical angle, and I'm going from the glass into the air. Okay? You cannot do it from air into glass. It has to go from glass into air. So, how do we calculate it? Snell's law, as always. If I'm looking for the critical angle, I'm going from glass, so we have a 1.5 sine of theta c is then 2. I'm going into the air, which is 1. And I know that if I'm at the critical angle, the angle of refraction, theta 2, is always 90. So theta c then must be the inverse sine of 1 over 1.5, which is 41.8 degrees. How can I change this problem? Well, I could say, what's the critical angle for glass where the light is going from glass to water? Well, the only difference is N2 would be 1.33 instead. Because I'm not going into air, I'm now going into water. But you're always going to do it the same way. Now, of course, if you remember, if you're fine with memorizing stuff, you just remember this, that the critical angle is the inverse sine of N2 over N1. That's okay. In fact, if you look in textbooks, they'll give you this equation. But as I said, I have a very bad memory. And when I was in school taking physics class for the first time, we had to memorize all our equations. We didn't get formula sheets or take-home tests or anything. And since I have a bad memory, I can't memorize a lot of formulas. So I learned to have the least amount of equations necessary to solve everything I have to solve. And since I know I could solve critical angle using Snell's law, and I already have to know Snell's law to do refraction, then why would I worry about trying to memorize this stupid equation when I've already had to memorize this one? So I just use it. It's less I have to remember. But that's my own weakness. If you can memorize a whole lot of equations, then if you wanted to start with this equation right here, that's perfectly fine. So that's critical angle. There's really not a lot of variety to these. At the end of the day, you're going from a more dense medium to a less dense medium. You want to know what angle is necessary to have theta 2 be 90 degrees. And then you solve for it. And really, that's about it. Obviously, there's not too many versions of these questions. All I can do is change. Am I coming, what's the first medium? What's the second medium? Or do I have multiple layers? Or am I doing a critical angle formula? The only difference is, well, what are your media? Is it air and water? Is it air and glass? Is it glass and water? Water and glass? What are these media I'm going to use? But once you know them, you're always using Snell's law, and you're just plugging numbers in and solving. So that's pretty nice. It makes these questions easy to do, less to worry about, and less thinking, which is always good. So I hope these examples helped you out, let you see how to think about these questions, and then allows you to practice the problems yourself a little bit more efficiently. So until next time.